Welcome everyone, and thank you for joining us today. Today we are presenting Unit8 Talk Season 5. This is the launch, so we are really happy to have you with us. And we are live today on LinkedIn, on YouTube, and on Twitter. So this session is for you. During all the event, you can write comments and questions, and we will try to answer them as soon as we can. And if not, we will do that directly on your platform. So today, for those of you who are new, let me introduce you a bit about ourselves. We're Unit8, a Swiss data analytics and AI company driving the digital transformation in the industry and committing to sharing our best practice and knowledge. And today, for the episode of Unit8 Talk, we'll discuss forecasting and how to use time series forecasting in your company. This episode will be recorded and will be available on our YouTube channel within around 4 weeks. On the first part of our agenda, we'll have our expert that will discuss the technical aspect of time series forecasting and share with you the release of our in-house tool, DARTS. And on the second part, we'll have our guest, Valerie Manokin, machine learning researcher and probabilistic forecasting and lead data scientist at a Fortune 500 company, when we can discuss real-life challenges and use cases. If you don't have anything to ask for now, we're going to introduce and kick off with the introduction of our speakers. The floor is yours, Francesco, Gael, and Julien.
All right. Hi, everyone. I'm Francesco, and I'm a data scientist at Unit8. I've worked at Unit8 for 1.5 years. Been involved in projects in various industries such as finance, energy, pharma, and I've also been one of the main, I suppose, contributors of our DARTS open source library.
Hi everyone, my name is Gael. I'm also a data scientist at Unit8. I've been working there for 3 years. I've worked especially a lot with time series in a telco industry a few years ago.
Hi, I'm Julien. I'm a lead data scientist also at Unit8. I'm involved in several projects that we have, and I'm also the creator of DARTS.
Okay, I guess we can jump into the presentation. Billy, if you can put my slides in up. Okay, I guess we have a small technical problem as Billy is the administrator, so he's the one that can change the screen. We wait a bit until he's back, but maybe I can already start a bit. Perfect. So now here we go. So before we jump into maybe the meat of the forecasting topic, it's, I think, always good to reiterate why forecasting is important. And for that, I want to walk you through 3 examples from different industries. So the first one is in retail. So as you can imagine, a retailer or a company need to match the amount of product it has to demand of customers. And if they fail to do so, for example, by having too much inventory, then that's going to cause them to store that inventory. Also, some cash is being locked in these products, and maybe even some perishable item will need to be removed. If they underestimate it, then they cannot sell the products. And so they really need to be able to anticipate the demand very precisely. In the energy sector, you probably know there are no solution for storing large quantity of energy. So there it's really important to accurately match the energy production to the demand. And this can be particularly difficult, especially in recent time with like solar and wind turbines. That can be pretty difficult to predict and anticipate. Finally, in the telco space, as internet traffic is growing, companies need to anticipate the infrastructure that they'll need for 2 days for peak hours, but also in the future for and this cannot be done very quickly as you need to scale the infrastructure, which takes time. And so you need, again, to anticipate demands here. So in all these cases, we have plenty of information about the past, but we need to know what the future is going to look like. And in other words, this is we want a forecast. And more precisely, we can frame this as a time series forecasting problem. At Unit8, we worked on quite a few of these forecasting problems, and I will walk you through 3 of them that we've done, and also how we kind of had some impact with them. The first one is in the financial and sales forecasting domain for a global chemical company. And there, a key contribution that we made was to also integrate some other indicators, so forward-looking indicators like future sales, to improve the accuracy of the forecasting algorithms, and as well as automate the forecast to reduce cost and reduce the amount of errors. Another case was slightly different, where there we needed to predict the residual value of a portfolio of car. And in order to have an accurate model, you need to have a lot of information to get an accurate model of the value. So there's a lot of data sourcing and cleaning to bring all the necessary information to the model and be able to produce a clean forecast. Finally, a different project and different challenge there was for a supply chain company, that retailer company that had some problem with out of stock items. Here, we needed the people to have a good forecast, but also to be able to take decision and actions based on the results of the forecast. So if we predict that an item will go out of stock, enable people to simulate solutions. So for example, moving goods from one place to another, or ask a supplier to be refilled. And this is how we managed to reduce by 50% the number of out of stock items. But today, nevertheless, we want to talk about the centerpiece, the forecasting techniques themselves, and let's jump into that now. So as you are probably aware, the forecasting field has evolved quite a lot over time. So way back in the day, we were probably relying on intuition and business acumen of key people within the companies. But in the 1950s, 60s, some statistical techniques evolved, and they allowed us to start using data as a way to feed the forecast. Of course, these techniques have some also limitation, and we then try to move towards some more quantized approach, where instead of having a point forecast, we can also get more information about the quantiles. So for example, if we want to meet the demand for a product at 99%, what would be the inventory value that we would need there? And then these techniques evolved towards modeling the full distribution to simulate even more scenarios. Nowadays, a lot revolves around ML models, which have started to show some promising results. And even current techniques are going to evolve in the future to make them easier to use, more interpretables, and even unlock some new fields like metalearning. At Unit8, key moments for us that really showed and concretized the promise of ML models have been the publication of NBITS in 2019. And NBITS is a pure ML models that is generic. And what this paper has shown is that in the case of a competition like the M4 competition, which is a kind of global forecasting competition, it produced better results than statistical or even hybrid ML and statistical methods. And this was kind of the first really model, purely ML, that achieved such results. So now I will hand the floor to Francesco to introduce a bit to some of these key ML models like NBITS and how they are very exciting.
Yeah, so exactly, continuing on this topic of ML models, I'd like to briefly talk about some of the most important recent developments that have taken place in the field of time series forecasting, and in particular with deep learning models. So the 3 main developments I want to focus on are metalearning, interpretable forecasts, and the use of external data. And I want to illustrate these 3 topics using 2 forecasting models from the last couple of years. So These two models are NBEATS, which Kyle already mentioned, and TFT, both of which were able to produce state-of-the-art performance on specific time series data sets. And both of them were first released in 2019. So for NBEATS, the authors of this paper argue that their model was successful in part because of a process called meta-learning, which I want to talk about later. What's also interesting about this model is that it provides a way to interpret forecasts, which we will also take a look at. But it is strictly univariate, meaning that it has no way to incorporate external data, which is also why I want to talk about the TFT model, so temporal fusion transformer, which has a very broad support for external data. And it also supports meta-learning and model interpretability, although it takes a bit of a different shape than in NBEATS. What's important here is that these models are generic, so there's no need, for example, for explicitly specifying seasonality, which then has to do with the frequency of the time series or anything like that. So this is quite different from these more statistical approaches from the past. So let's delve into the first topic I want to discuss, which is meta-learning. And I want to use NBEATS as an example for this. And again, the creators of this model argue that it is really one of the reasons for its effectiveness is the fact that it performs meta-learning. So broadly speaking, we can say that meta-learning involves training a model on many different time series and extracting general principles from this training that are useful to then forecast any individual series. As an example, we tried this ourselves using our DARTS library on a simple time series. So first, in this block of code, we first train our model on a large data set of all kinds of different time series, which does not include actually the series that we are trying to forecast. Then we take our target time series and provide it as an input to our trained NBEATS model. And that way, we're kind of producing a forecast for a time series that we didn't train on before, and which is in that sense a zero-shot forecast. And as you can see, the performance is pretty good, and we checked that the series was indeed not in the training data set. So this is kind of interesting. And in fact, if you do look at the training data set, here's just a random sample of the training set. Obviously, the training set is much bigger than this. But as you can see, there's a very high variability in terms of what we actually fed into the model during training. And none of them, really look the same as our target series. So what's happening here is that NBEATS manages to extract general properties of how time series tend to develop and is able to transfer this knowledge to an unseen time series. So that would be small intro to meta-learning. So now let's talk about model interpretability. So this is all about understanding why a certain prediction was produced. Let's continue with NBEATS and look at the possibility it offers to explain forecasts. So this shows a very simple example of what an NBEATS explanation could look like. So on the left, we see a actual time series in blue and the interpretable forecast in orange. And here on the right side, we see separate outputs for trend and seasonality predictions of NBEATS. So the sum of these two separate outputs is equal to the final NBEATS prediction. So this ability to separate various trend and seasonality predictions is something that's unique to this model and is a function of its architecture. So the explanation here takes the form of the model predicts this time series because it sees this trend and this seasonality. So that's already definitely valuable in some cases. But there's many other ways that you could look at the topic of interpretability, and that's also what the TFT model does. It's quite different. So please don't worry too much about the details of this diagram. I'm just showing it because the two ways in which TFT forecasts can be explained is reflected in the two distinct modules of the architecture. So the first one is indicated by the arrow on the left, which points to the self-attention layer. So, I mean, this is a module that is also, of course, it wasn't invented by this model, but it helps this model to not only produce better forecasts, but it allows us to check which time steps were relevant to the model when producing a certain forecast. So in that sense, it helps us understand the model predictions better. But if we feed the model with multiple data points for each time step, for instance, we don't know which ones were most relevant, right? We just know which time step was the most relevant. So this is where there is another explainability mode, which is implemented by the module you see on the right, pointed to by the arrow as well, by the other arrow, which is the variable selection network. And looking at the coefficients that this network produces, we can learn which features, regardless of timestamp, contributed the most to our result. So both of these ways of interpretation are quite different from the NBeats one, but together they definitely form a powerful tool for understanding major contributing factors to forecasts. And just lastly, to wrap this up, I want to touch upon the topic of external data. There are tons of different types of data that could be useful for forecasting it. And up until recently, most models could not deal with all these types of data at once. So it really depends on, what is the problem at your company that you want to solve, that then determines which data is most useful. And the nice thing about the TFT is we have a model that is extremely flexible when it comes to using any type of external data that could be predictive of the target variable. So be it past covariates, something you only know up until the present, or future covariates, something where you also know the future value of, such as holidays. So this model encodes all of this in such a way that all of the information is integrated and produces a final forecast that, considers everything. And lastly, I just want to...
Francesco, before you go to that, I just want to interrupt just for a few questions. We have a question
Absolutely,
on YouTube that asks, is there a general rule of scaling training series for NBeats?
Is there a rule for how, the runtime scales with what type
Maybe
of scaling?
the scaling of the values, perhaps. So all these neural networks, they need, like most of the deep learning models, they need values to be sort of normalized or standardized between 0 and 1 or something along those lines. I don't know if that's what the question means, but I assume it's the question.
I hope that answered the question.
We have another question. Is the TFT model transformer based? Yeah, kind of, right? It's based on multi-head attention.
Yeah, so it definitely uses a core element of the transformer. Yeah.
Thanks, guys.
And okay, so to wrap this section up, I just want to quickly at this point that, while the authors of these papers produce great results using their new fancy models, it is often super time consuming to re-implement everything they did and adapt it to your specific needs. So, rather than starting from scratch, we really suggest, when you want to try out these novel approaches in a project at your company, you don't want to start from zero. So to us, one of the best ways of doing this is to use a well-maintained forecasting library that is continuously updated to reflect the state of the art in forecasting algorithms. So, and this is exactly what we're trying to provide with darts. Having said that, this presentation is not specifically about darts. So actually now I would like to pass the mic back to Billy to introduce our guest.
Thank you very much, Francesco. Thank you, Gael. It was a very rich set of knowledge. And now we're going to introduce our guest, Valerie.
Yes, thank you, everyone, for having me on this session. Very exciting. Glad to see the library Darts is developing very nicely. I've come across it a couple of years back, and it seems to be picking up, in terms of development, right? So just a few words about myself. I'm a lead data scientist at Stanley Black & Decker, which is a large manufacturing company across 3 continents. Have been focusing mostly on the operations side, solving high-impact business problems for the company, both in forecasting and predictive maintenance, anomaly detection space. I've been working with time series for quite a while. Also completed my PhD in probabilistic prediction in University of London. So focusing on conformal prediction, which is a form of prediction, which allows to basically quantify uncertainty around any classifiers or predictors, whether they're machine learning or statistical. So yes, I mean, happy to discuss any questions or what you would like to talk about. Thank you.
Thanks, Valerie. Thanks a lot for attending and coming to this discussion. It's very nice to have you here, especially because you have lots of hands-on experience also on forecasting. So I wanted to ask you a couple of questions. We unfortunately don't have so much time. But I think it would be nice if you could tell us a bit, perhaps, about one project or use case where you had to use forecasting and sort of the takeaway lessons that you took from there.
Sure. Yeah, I mean, I can talk. One of the projects I did was to improve forecasting accuracy. Right, in particular, it was related to intermittent demand. So just to explain, intermittent demand is something which is when a company sells products, right, which is not fast-moving consumer goods, a lot of industrial companies, for example, in this space, are selling products, sporadically, right? So which means not every month. It's a very hard problem, right? It's not completely solved. So I can tell how we approached it, right? There are certain dimensions one can work with when starting to deal with a forecasting project, right? In my experience, the most kind of productive, profitable approach is first, start looking at what data is available, right? What are the algorithms, right? So many companies have enterprise systems in particular, so we need to understand what's inside the box, right? So kind of go into documentation, go under the bonnet, under the hood, so to say, check out what algorithms are there. And and another thing is like we try not to reinvent the bicycle, so to say, right? So there is a lot of good algorithms in econometrics and statistics, right? So usually it sort of goes into phases, right? We need to kind of see what the benchmark is, of course. How do we measure value, right? There is this approach in applied forecasting which is called forecasting value added, right? So we need to establish some sort of benchmark, right, and to see whether it's actually our efforts are providing tangible impact, right? So the benchmarks, they could be a different kind, right? So if you have fast moving consumer goods, for example, fast-moving data, usually naive forecast is something that works quite well, especially for...
Yeah. And just a quick question, because you mentioned intermittent series. I think this is really interesting. But there, when you work with a, let's say, business, what's the output of such a forecast, and what do you tell them? Do you tell them, okay, there is a probability of 0.2 that you will sell something next month?
Yeah, no, it's a good question. So actually, intermittent demand it's quite specific in that it's sort of like looks at it in a slightly different light, right? So as you correctly mentioned, thank you for this question, Julian. It's very difficult to say, like, okay, what are we actually trying to forecast, right? And the most straightforward, like impactful from a business viewpoint way, and it's actually a lot of things we can learn from like applied forecasting, academia and so on and so forth. We actually try to kind of rephrase the problem slightly, right? So all we're interested from a company viewpoint is not to forecasting, every month what's the probability of this good being sold and how much, right? But we actually kind of slightly tune it and we turn it into like how much we're gonna sell over the lead time, right? So say, we know our lead time is like 3 months or 6 months. And for companies, if we can forecast at a certain level, right, a constant level of the 6 or 3 months, that's sufficient, right? Because we just don't want to be out of stock and we don't want to overstock. And this is kind of the way to look at it. So what we're actually interested in the kind of cumulative demand over the this kind of forecasting period of time, right?
Okay. Yeah, that makes sense. And I just wanted to ask you also, for you, so what are your go-to tools? So you already mentioned, first part obviously is identifying the best models. Sometimes often no need to reinvent the wheel, which makes a lot of sense. What are your go-to tools that you use? Are you more like an R person, a Python person? And
very interesting question. I would say again, if we look at kind of regular forecasting problems, right? Like fast moving, this is quite straightforward to solve, right? So people have a lot of algorithms, right? There is Dart, there is other libraries, there is deep learning, so it's quite straightforward to benchmark. One thing I would like to mention is, of course, like two dimensions to look, at the problem from, right? One is time series dimension, and another one is, I think, it's also like very productive way. When we listen to Rob Hindman's research in particular, for example, we can actually convert time series into features, right? There are libraries for that, right? So we can actually go from, because this is we know that for tableau data, there is a lot of algorithms that actually work. So we need to do this first step to convert time series to a tabular problem, and there are two ways to do it. One is like time-based features, and the other way is to convert it into some other features, right? For example, there is a library called tsfresh. So for fast-moving, quite simple again. For intermittent, a bit more complicated. I would say R used to have sort of more focus on time series historically. Both on from statistical perspective. Of course, there is AutoArima. I feel there has been a lot of development during the last couple of years in Python ecosystem, right? So,
what excites you the most about the future of forecasting? You already mentioned it.
What excites me most, I think, given where most of the companies are, right? Of course, there is a lot of exciting innovations in AI, NLP, and computer vision. But from a point of view of 80% or maybe 90% of the companies, actually, a lot of value is locked in the tabular data or time series data in particular. I think there is a lot of good things, for time series going forward. Yesterday, Amazon has released a new package, in Gluon 2S, which is using, conformal prediction kind of like approach that allows to also forecast uncertainty. So I think the future is for time series is non-parametric and also like uncertainty based, right? So for companies to make decisions, we need to understand the whole kind of distribution, right? So we want to know what is going to be the distribution of demand for next month, because that helps companies to determine optimal stock, to manage working capital, to control costs and things like this, right? So I think this is where the things are moving from, to, right?
Yeah, definitely with you on this one. It's also something we're trying to bring on Dart. It's a strong component. We're trying to have probabilistic forecasts for as many models as we can, and all of the deep learning models, actually. In the next release, we'll have a probabilistic version of n-bits, which would be quite cool, I think.
It's quite exciting. Thank you. Looking forward to it.
Thank you a lot, guys. Just to tell you that we are at the end of the webinar, so if you have a last note, is the moment to share.
Any last thoughts? I don't know. Maybe we can take questions also from the audience.
We have a lot of questions, actually. I can show the last one.
Yeah, I think anyway, some of the questions about Dart, you can also reach out to us offline, darts@unit8.com. And I don't know, Valerie, if you have any sort of last thoughts or concluding.
I mean, I think for people working in the forecasting space, time series space, it's a very exciting time. So my recommendation would be just kind of try to to understand both from industry and company viewpoint. There is a lot of good expertise over there, right? So people who are doing demand planning, work with them to help them, to get trust into algorithms, right? Follow the academic papers, follow the open source libraries. There is a lot of exciting stuff, published by Amazon, by some key research labs in the UK, in the US, in Australia, right? It's very exciting, I think, domain for both research and the industry going forward.
Yeah, I agree.
Thank you, guys. It was a very interesting discussion. So that's the end of our event today. I want to thank you all for joining us. I want to thank as well our speakers, Julien, Francesco, Gael, and Valerie, our special guest for today. For all of you who have been following us, I know that there were a lot of questions we weren't able to answer today, and we'll try to do that in the next few days on the social media directly. For those of you also who are also still there, I told you there will be a few surprises. First one is that we're preparing the launch of our time series forecasting program that will deliver forecast results for your specific use case based on our engine within a few weeks. So if you are interested to know more about it, contact us directly, write us comment on unit8.com, and we'll get in touch with you. The second thing is that we are launching the next month on December 8th, a special edition of Unit8 Talks that will be a roundtable about advanced analytics trends 2021 and 2022, hosted by our CEO, Marcin, directly, with some surprise guests. So stay tuned and also follow us on all the social media to be updated. I will put the link directly in all the social media so you can see the event and stay tuned for that. For those of you who are not yet in our list, you can join our newsletter, go on unit8.com, and you can join for the last trend and best practice of the industry. Again, it was a pleasure to have all of you, and I wish you a great evening.
Thank you.
Bye-bye and see you soon.
Everyone.
Thank you.
Thanks,
Bye-bye.
everyone. Bye bye.